Alright, so here we go. We're going to get into some of the more complicated topics, and this next one is, it's a bit of a doozy to be honest, but it's actually really applicable. We're going to talk about particle systems. Now, particle systems are, well, they're used for a lot of different things. We're going to simplify it and use it for some of the most common things like explosions and whatnot. But particle systems are used in a very large variety of things within games and animation and whatnot. They could simulate things like water effects, like fluid dynamics, or they could simulate fire. We're going to use it for like the explosions, like big booms, particles flying away, firecrackers, stuff like that, water fountains, things like that. And what you're going to see is a lot of really cool effects that are going to use the exact same system, and all we have to do is tweak some properties, and that's going to produce a totally different outcome. Now those other things like fluid dynamics and fire and things like cloth and hair, they use particle systems as well, but they do it in a different way. Our particle systems are basically projectiles. The way that those particle systems work is they have a big grid of individual little items, and when you tweak one, such as move its location, everything else around it is slightly adjusted. Imagine if you had, let me just draw a quick little picture for you here. Let's go to draw. Imagine if you had like a blanket. And you pinched a little piece here and you kind of raised it up. What happens is that all the little pieces around it kind of get risen up as well. The farther away it is, the less dependency, the less pull that your little pinch has on the whole thing. So though if the whole thing was made up of like a grid of individual particles that went through the whole thing, the ones way over here really wouldn't be affected that much by the pinch up there. Whereas the ones right around it would actually be affected quite a bit more. So it actually loses its effect the farther away you get. So that's one way a particle system works. But what we're going to do is imagine like you have a screen and you have a location where everything, think like a volcano or something like that. Very simple, oops. Sorry. A very simple volcano, and what we're going to do is we're going to create all the particles that are going to fly out of this volcano. Explosion, 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 blah, blah, blah. Or like a firework, when it gets up, hits this point, and everything flies out all around it in all directions. So these are the simulations that we're going to use particle systems for. Now, in theory, particle systems are very simple in nature. Basically, we have what's called an emitter. An emitter is a location on the screen that emits particles. So for example, in the volcano's setup, the emitter might be the center of the volcano, or the emitter location I should say, and everything shoots out from that point. For the firework, it might be where the explosion point is, and everything shoots out from that point. So that's our emitter. So the emitter is made up of a whole bunch of particles. Now these particles are basically projectiles. Now we've already had a projectile discussion before, and we're going to use, in fact, what you're going to see in the demonstration is that I've actually copy and pasted about 90% of the code with only a few little tweaks. It does have a few small additions. One thing about a particle system is that the particles have a lifespan. They only exist for so long. And there's two types of particle systems, and when we talk about these explosive particle systems. One is where it's a one-time shot where everything explodes at once, like a firecracker. Others are cycling particle systems, like this volcano, where the particle will fly out, fall down, eventually die. The time will run out and it'll die. Well, what happens when it dies? It doesn't really die. It gets recycled and put back to the emitter location and then fires out again, maybe in a different direction. So it's a cycling particle system. So those are our two possibilities, all at once or a cycling system. And we're going to look at both of them because it's very simple tweaks that we have to do to actually make that a possibility. So this lifespan is the extra little bit that we're going to put into each of our projectiles. So basically the projectile will continue on its projectile path as normal until its lifespan ceases to exist, and then it gets recycled back to the emitter and launched again whenever it's ready to. So that's about it. So our particle system, so our whole system is going to be made up of 3 classes. We're going to have our main class, which is going to be made up of an emitter, and this emitter is going to be made up of who knows how many, 1, 2 star particles. So we're going to be using classes as well. So we're talking about projectiles, we're talking about classes, which is why you've had to go through those lessons before you could even get to this lesson. And this is their whole system. Now, in theory, your driver class could actually have more than one emitter. So imagine like you're playing a game and the person's shooting bullets all around the screen. Whenever it hits a wall, it creates a little particle system that fires concrete pieces off from that wall. Well, you're never only going to have like one bullet on the screen at once, so it's possible that you might have like an array of emitters, or an array list of emitters, or a list of emitters, depending on what language you're working in. So it doesn't have to just be one. We could actually say from 0 ... to star here. But every one of those emitters has its own collection of particles. So you need to realize that. So that's the setup we're going to look at. And just so you can see roughly what we're going to talk about in the next module, we're going to look at this. This is the class structure for each of these setups. Now, like I said before, it is quite a bit more complicated than anything we've done in the past, but this is everything that you're going to need to know. All right, we'll get into that next lesson.